Welcome back. I'm Blue Dolphin with the Hoplite Security Channel, and in this video we're going to be getting into the Deloitte Hack Holiday 2021 Space Race Quantum Snacks Challenge. Let's get into it. And jumping right into the challenge here. It looks like it's going to be a tough one. 3 flags, and it is a logic gate. So let's read the challenge information. Computers speak the language of binary, zeros and ones. And every computer program is basically just applying logic gates, not, or, and, XOR, to these bits to get a desired outcome. The important point here is to remember that a bit is a single variable and can have one of 2 values, either 0 or 1. Quantum computers speak very different language. Instead of a bit, we have a qubit, a quantum bit, which can be represented as a 2-dimensional vector. Classical bits 0 is equivalent to the qubit 1 over 0, and the classical bit 1 is equivalent to the qubit 0 over 1. But there are many other qubit states. Oh, sorry, I just changed pages there. But there are many other qubit states that do not have a classical equivalence, which means that qubits can store much more information than classical bits. The goal of this challenge is to understand this concept better. To change the state of a qubit, we apply logic gates to it. In quantum computing, logic gates are represented as matrices, and the outcome of this operation can be calculated by multiplying the logic gate, a matrix, with the initial qubit state, a vector. Mathematically, it looks like this. Okay. So we have the matrix here, interesting. In this challenge, we limit ourselves to 3 1-qubit logic gates. And then there's a note that in practice, there are more logic gates that result in infinite possible quantum states. Because we're only considering 3, the number is different. Okay, now down here, it just talks about nothing relevant. Okay, so let's look at the first leg. Consider only 3 logic gates, and starting in the 1, 0 state, how many states can the qubit have? Hint, start apply. Oh, I see. So we could draw this out. Alternatively, we can just use the matrixcalc.org. So we can go matrixcalc.org. This is unfortunately loaded in a totally different language, which is odd. Let's do /en. There we go. Okay, so we have our logic gates. Let's do 1, 0. Let's load them up. And for this challenge, we just need to think how many permutations are there if we go through this. And we know initially that right here we have 3 outcomes. 1, 2, 3. Well, we could flip all these and put the bits in the bottom, and that would give us 6, because that would be 3 more states. And then from here, we can only change 2 of the gates to get a desired, a different outcome, true or false. So that would give us 8. Ooh, I think. Let's see here. Awesome, it worked. Okay, that was easy. Let's look at number 2 here. Make a circuit. Provide a circuit, a series of operations that transform the 1, 0 state to the -1, 0 state, only using H and X operations. A possible wrong answer is this. I have absolutely no idea what to do. Just make us. Okay, well, we're just gonna wrap it up here at Quantum Snacks. I just really don't know what to do. So anyways, see everyone in the next video.